Question 12, Part A. The vectors a squared 2 and a plus 5, a minus 4 are perpendicular. Find the possible values of a. Two vectors that are perpendicular or 90 degrees to one another have a dot product of 0. Hence a squared times a plus 5 in brackets plus 2 times a minus 4 in brackets equals 0. Expanding the brackets on the left hand side of this equation, we get a cubed plus 5a squared plus 2a minus 8 equals 0. Now we've formed a cubic polynomial equation and we want to find the values of a such that the left hand side of this equation is equal to 0. Now we can use polynomial techniques to find possible zeros. One way we can do that is to consider the factors of the constant term 8. And the factors of 8 are 1, 2, 4, 8, negative 1, negative 2, negative 4, and negative 8. We can use the factor theorem to check each of these factors by substituting those factors for a in the left-hand side of this equation and then evaluating the left-hand side of this equation, checking to see that it's equal to 0. And if it is, then we've found a value of a that solves this equation. I didn't show the substitution in this solution, but it's easy enough to do. So checking these factors of 8 one by one, I found that the left-hand side is 0 for a equals negative 4, a equals negative 2, and for a equals 1. Therefore, the possible values of a are negative 4, negative 2, and 1. As a side note, a cubic polynomial equation, that is a polynomial equation of degree 3, similar to the equation that we just solved, will have no more than 3 real solutions by the fundamental theorem of algebra. And it just so happens that we found 3 real values of a, that is negative 4, negative 2, and 1, that satisfy this equation, which is why we can end the solution at that point. If we only found one possible value of a by considering factors of the constant term, we may then need to use polynomial division to try and find other possible values.